Right now, Oklahoma City, Omaha, and Minneapolis are all under severe weather threat from the same storm system. It has been battering the plains and Midwest for 3 consecutive days from August 17th through today, August 19th. Ord Municipal Airport in Valley County, Nebraska recorded a peak wind gust of 90 miles per hour during this outbreak. That is the equivalent of a Category 1 hurricane produced by a thunderstorm. More than 60,000 Nebraskans lost power to the system's wind damage. A grain elevator in Ord was destroyed. The town's schools canceled their first day of the school year. 4 Nebraska counties, Garfield, Greeley, Valley, and Wheeler, were all under tornado warning in a single day, issued by the National Weather Service office in Hastings. Earlier the same week, a Derecho put a 99 miles per hour wind gust down in Gary, Indiana. This is not one storm passing through one town. Something significant is happening. Today we are going to break down exactly where this outbreak is hitting and what the Storm Prediction Center is actually forecasting for the rest of the day. We are also going to cover what it means for the millions of people living underneath it. No guessing, no dramatizing, just the facts, the science, and the real stakes. If you are in Nebraska, Iowa, Kansas, Missouri, Minnesota, or Oklahoma, drop a comment right now. Has your phone gone off with a warning in the last 3 days? Did the power stay on? Just name your town. That is all it takes. Subscribe to Earth Dispatch. This outbreak is still active and the Storm Prediction Center is updating its outlooks throughout the day. Subscribe now so the next update on this system reaches you before the next storm does. Rewind to August 17th. That is where this outbreak begins, not as a single violent event, but as the first chapter of something that has been building for 3 straight days. On August 17th, the first round of severe storms pushed into the Central Plains with heavy rain, large hail, and damaging wind gusts. The system was not immediately catastrophic. It was, in meteorological terms, a significant severe weather event, the kind that generates warnings and knocked out power in scattered areas. But it did not stop. It reorganized overnight and pushed back in on August 18th with more intensity and a wider footprint. And here on August 19th it is running again. That 3-day continuity matters more than it might first appear. When people talk about severe weather, they often talk about individual storms, individual events, individual warnings. But what is happening across the plains and Midwest right now is a single continuous atmospheric pattern that has been producing dangerous weather every day since Sunday. That is a different kind of threat. It is cumulative. It compounds. And by day 3, the region is no longer starting from a rested state. The events of August 18th tell you exactly what kind of pressure this system has been putting on the region. On that day, the National Weather Service office in Hastings, Nebraska, issued tornado warnings covering 4 counties in a single day: Garfield, Greeley, Valley, and Wheeler. 4 counties under tornado warning in one day, all from one office, all from one system. That is not a routine afternoon for a region in August. The anchor story of Day 2 is Ord, Nebraska, a small town in Valley County, and what happened there illustrates what this outbreak has been doing to communities that sit directly in its path. Instruments at Ord Municipal Airport recorded a peak wind gust of 90 miles per hour. To put that number in physical terms, 90 miles per hour falls well within Category 1 hurricane wind speeds on the Saffir-Simpson scale, which starts at 74 miles per hour. A Category 1 hurricane produces winds powerful enough to snap branches from mature trees, tear exterior siding from buildings, and knock over unsecured structures. In a coastal context, those winds would have meteorologists issuing life-threatening storm surge warnings for a coastline extending hundreds of miles. In Valley County, Nebraska, those same winds arrived without a hurricane, without a coastline, and without a name. They came out of a thunderstorm. The damage in Ord reflected the force behind that number. A grain elevator in the town was destroyed. Trees and power lines came down across the community. More than 60,000 Nebraskans lost power across the region as this system's wind damage accumulated. And that number, 60,000 people without electricity, translates in practical terms to 60,000 households running on whatever backup capacity they had. Flashlights, car chargers, generators for those who owned them, and nothing at all for those who did not. For the town of Ord itself, the immediate and visible consequence was that the school district canceled the first day of the school year. Not a weather delay, not a late start. The first day of the year canceled because the storm that came through the night before left conditions that made it unsafe to open. A derecho also factored into the week's damage picture before the August 17th outbreak even began. A derecho is a long-lived, fast-moving band of damaging straight-line thunderstorm winds. Not a tornado. Nothing is rotating. The wind simply comes from one direction, hard, for a long time over a long distance, sometimes hundreds of miles. Derechos are responsible for some of the most widespread wind damage events in the central United States because they do not require the narrow, concentrated track of a tornado. They hit broad swaths of territory all at once. The derecho that struck earlier in the same active week produced a 99 miles per hour wind gust in Gary, Indiana. 99 miles per hour of straight-line wind. That is well into Category 2 hurricane territory for sustained speeds, arriving not from a named Atlantic storm, but from a convective system rolling east across the Midwest in August. A tornado warning, which the National Weather Service issued across all 4 Nebraska counties on August 18th, carries a specific and unambiguous meaning. It means that a tornado has either been spotted on the ground or that Doppler radar is showing rotation in a thunderstorm strong enough to produce one. A tornado warning is not a heads-up. It is not a watch that says conditions are favorable. It is an instruction to take shelter immediately because the threat is immediate. Those warnings cover counties that are home to farms, small towns, and rural households where the nearest storm shelter might be a mile down a gravel road. When storms run on back-to-back days, the second day does not start from zero. And that is exactly the position this region is in today. The ground across parts of Nebraska, Iowa, Kansas, and Missouri absorbed heavy rain on August 17th and again on August 18th. The trees that survived day 1 went into day 2 already stressed. The power grids that took hits on day 2 are running on emergency repairs going into day 3. And the soil that soaked up 2 rounds of heavy rain is sitting at or near saturation capacity, which means whatever falls today has very limited ground to absorb it. That is not background noise. That is the foundational condition underneath everything the Storm Prediction Center is saying about August 19th. The Storm Prediction Center, which is the division of the National Oceanic and Atmospheric Administration responsible for issuing severe weather outlooks for the contiguous United States, has placed northeast Kansas into central Missouri under a level 2 of 5 severe weather risk for today, August 19th. That category is called a slight risk. Level 2 of 5 means the SPC's second lowest tier of 5 threat categories, ranging from Level 1, which is a marginal risk with only isolated severe storms possible, up through Level 5, which is a high risk reserved for the most dangerous and widespread outbreak days. A slight risk sits just above the floor. It is worth pausing on that number before moving forward because Level 2 of 5 sounds, on its face, like a relatively minor designation. It is not. A slight risk means that scattered severe storms are expected, not just possible but expected, across the area under the outlook. The word scattered is doing a lot of work in that sentence. Scattered means the storms will not blanket the entire region simultaneously. It means they will not form a solid line of destruction from Kansas City to Minneapolis. But it also means that individual storms will reach severe criteria, and will hit specific places. If you are in one of those places when one of those storms arrives, the fact that the overall category is level 2 rather than level 4 is not information you can do anything with. The storm hitting your town is the storm hitting your town. The primary hazards the Storm Prediction Center is named for today are severe wind gusts and isolated large hail. That framing is important because it tells you something about the structural character of the storms expected for August 19th. The SPC is not leading with tornadoes as the primary risk for today. That is partly because of a shift they are forecasting in how the storm system itself is organized through the day. That shift involves a concept called vertical shear. Vertical shear describes how much the wind changes in speed and direction as you move up through different levels of the atmosphere. The relationship between shear and storm type is one of the more important dynamics in severe weather forecasting. Strong vertical shear, where winds at high altitude are moving significantly faster or in a different direction than winds near the surface, tends to keep individual thunderstorm cells rotating and organized. That rotation is what creates the conditions for tornadoes. Strong shear favors discrete supercell thunderstorms, the tall spinning storms that produce the most significant tornado events. Weak vertical shear does the opposite. When there is not enough difference between low-level and high-level winds to sustain individual cell rotation, storms tend to lose their discrete structure and collapse together into long lines. Those lines are called squall lines or bow echoes depending on their shape, and they trade the tornado risk of a supercell for a different kind of threat, widespread damaging wind and hail across a broad front rather than a concentrated rotating column. Today's forecast includes weak vertical shear, and the SPC expects that condition to push the storm mode progressively from cellular, meaning separate rotating storms, toward linear, meaning a long organized line of storms moving through the region. That shift does not eliminate the tornado risk entirely, but it does mean that as the afternoon progresses, the character of the day's hazard changes, and the most likely severe event transitions from a tornado-producing supercell to a powerful line of wind-producing storms. On top of everything the Storm Prediction Center is tracking for severe weather, the National Weather Service has issued a separate flash flood outlook for a substantial portion of the same region. The flash flood threat is rated at level 2 of 4, covering Iowa, eastern Nebraska, northern Missouri, and northwest Illinois. A flash flood is flooding that develops within hours, sometimes minutes, of heavy rainfall. Unlike river flooding that builds over days as upstream water moves downstream, flash flooding can put water in the street before the rain has stopped falling. It is particularly dangerous for drivers because roads that appear dry can be under fast-moving water within minutes of a heavy rain cell passing overhead. The standard guidance from NWS for flash flooding is direct. If you cannot see the road surface underneath moving water, do not drive through it. The water can be deeper than it looks, it can be moving faster than it appears, and the road surface beneath it may have been compromised. The National Weather Service has specifically flagged previously saturated ground as a risk multiplier for today's flash flood threat. That is not a routine note. It is a direct statement that the ground conditions across those 4 states, which soaked up rainfall on both August 17th and August 18th, reduce the margin between heavy rain and serious flooding. Soil that is already saturated from prior storms cannot absorb additional water the way it normally would. That means runoff happens faster, water collects in low-lying areas sooner, and the amount of rain required to trigger flash flooding is lower than it would be on a normal August day. In practical terms, a storm that would produce inconvenient ponding on a dry week can produce life-threatening flooding on a week when the ground has already been soaked twice. Fox Weather's rolling coverage of this system has described it as a dangerous multi-day severe weather outbreak threatening millions, and that characterization is consistent with the scope of what the SPC and NWS outlooks are showing. A risk category is a shape drawn on a map. The thing about maps is that people live on them. Oklahoma City has a population of approximately 700,000 people. Omaha has a population of approximately 486,000. Minneapolis has a population of approximately 430,000. All 3 cities have been explicitly named by forecasters as under threat today on August 19, 2026, the 3rd day of this same continuing outbreak. Stack those 3 numbers together, and you are looking at roughly 1.6 million people in major metropolitan areas alone, all sitting under the footprint of an active, multi-hazard severe weather system. That is before counting the suburban rings that surround each of those cities, the secondary cities within the outbreak zone, and the rural communities spread across the plains and Midwest that fall between them. Oklahoma City sits at the southern end of the current threat area. The city and its broader metropolitan region, which stretches well past the city limits in every direction, faces the same combination of severe wind and hail risk that the SPC has outlined for the region. Oklahoma City is not unfamiliar with severe weather. The city's emergency infrastructure includes an outdoor warning siren system, and the region has historically been among the most storm-aware communities in the United States. But awareness of severe weather as a general category does not mean any individual storm event is without risk. The hazards are real, and the populations underneath them are real. Omaha sits closer to the core of the multi-hazard overlap. It falls within both the severe weather risk area and the flash flood threat area that the NWS has outlined for eastern Nebraska. Omaha is also a river city. The Missouri River forms its eastern boundary with Council Bluffs, Iowa, and the city's stormwater infrastructure handles normal August rain events, but flash flooding from a saturated ground event on top of a 2-day rainfall accumulation is a different load than normal. The level 2 of 4 flash flood threat is not a guarantee that Omaha floods today, but it is a specific statement from the National Weather Service that the conditions required for flash flooding are in place, and that the probability has crossed the threshold for an official outlook. Minneapolis sits at the northern end of the threat corridor. The Twin Cities metropolitan area, which includes both Minneapolis and St. Paul and the suburbs extending outward from them, represents the northernmost population center explicitly named under this system's threat area. The same storm system that put a 90 miles per hour gust down on rural Nebraska on August 18th is the same system producing today's threat for a metropolitan area of well over 2 million people when the broader Twin Cities region is counted. The flash flood footprint on its own covers an enormous stretch of geography. Iowa, eastern Nebraska, northern Missouri, and northwest Illinois together represent a contiguous zone that includes large portions of some of the country's most agriculturally productive land, as well as several mid-sized cities and hundreds of small towns. The level 2 of 4 threat means that across all of those areas, the conditions for flash flooding are active, and the ground that would normally absorb heavy rain has been reduced in its capacity to do so by the storms that came before today. Urban areas have their own specific flash flood dynamics that are worth understanding. In cities, the surface is largely impervious. Pavement, rooftops, parking lots, and compacted soil do not absorb rainfall the way open farmland or grass does. Storm drains and sewer systems are engineered to handle a certain amount of rainfall per hour, typically based on the historical average for the region, not on scenarios where the ground is already saturated and 2 inches of rain have already fallen in the past 48 hours. When rainfall exceeds that design capacity, water has nowhere to go except into streets, underpasses, and low-lying areas. Urban flash flooding happens faster than most people expect. Underpasses can fill in minutes. Basements can take water before the rain is let up. And the instinct to drive through what looks like shallow water is one of the most consistently deadly decisions people make during flash flood events. The rural counterpoint to the urban threat is Ord, Nebraska, and it is worth returning to that town specifically because it represents what this system has already done to communities that did not make the national headlines. Ord is a town of approximately 2,000 people in Valley County. It has no coastline, no designated evacuation zone, and no hurricane preparedness protocol because Nebraska does not have hurricanes. It has a grain elevator, or it did, until this outbreak's 90 miles per hour straight-line wind destroyed it. That elevator is not a piece of agricultural trivia. Grain elevators are the storage and processing infrastructure that connects farms to markets. Losing one before harvest, in August, is a concrete economic wound to a community that depends on agriculture for its economic foundation. The trees that came down and the power lines that failed were part of the same event that canceled school on the first day of the year. For children in a town that has likely been anticipating that day all summer, no mass evacuations have been ordered across the outbreak zone. The National Weather Service guidance has been consistent. Have a way to receive alerts today. That instruction sounds simple, but its implications are worth understanding fully, and they connect directly to the situation on the ground after 60,000 people already lost power in this same outbreak. Which raises the question nobody in Nebraska is asking out loud today, but every meteorologist is. Why now? Why August? The United States tornado climatology has a well-documented seasonal peak. Most tornado activity in the country clusters in March, April, and May, the months when cold air masses from Canada are still strong enough to collide with warm, moisture-laden air streaming north from the Gulf of Mexico, and when the atmosphere is primed for the kind of violent mixing that produces supercell thunderstorms. As summer progresses and the cold air masses weaken and retreat northward, the atmospheric conditions that favor the most intense tornado outbreaks become less common. By August, the jet stream has typically retreated north. The temperature gradients that drive explosive storm development have weakened, and the Central Plains are spending most of their days under hot, hazy, relatively stable air. August tornado events happen, but significant multi-day outbreaks with simultaneous hail, wind, flooding, and tornado threats across a broad region are not common. That context makes what happened this week in Nebraska more striking, not less. Place Ord beside Omaha on the same map. The same storm system moves over both. The same 3-day outlook covers both. Omaha holds nearly 486,000 people with hospital infrastructure, outdoor warning sirens, trained storm spotters, and utility crews ready to respond. Ord holds roughly 2,000 people and a grain elevator that no longer stands. The 90 miles per hour gust that swept through Ord on Tuesday did not consult population density before it arrived. The town lost power, lost the elevator, and lost the first day of its school year. The headline Omaha would have generated from the same hit would have run nationally. Ord ran locally. Scale of damage and scale of attention are not the same measurement. The National Weather Service issued the level 2 of 5 outlook. The Storm Prediction Center drew the polygons. The alerts went out. But a forecast only completes its job when it reaches someone who can act on it, and that requires a phone with notifications on, a weather radio with fresh batteries, and enough baseline knowledge to understand what a significant weather day actually means before it arrives. Not fate, not luck, reception. Tell us in the comments, what does your actual alert setup look like? Phone notifications, a weather radio, a siren you can hear from inside with the windows closed, or nothing at all? And when the power went out this week, did any of it still work? If you are in Iowa, Nebraska, Kansas, Missouri, Minnesota, or Oklahoma, drop your county so people in your area can find each other. Subscribe because this system is not finished. SPC outlooks continue updating through the day, and we have continued coverage as Day 3 resolves into Day 4. And if you know someone in the flash flood corridor right now whose ground is already saturated, send them this video.